Hi everyone, Chloe here. Today we're going to talk about differential equations. So before I define what a differential equation is, I think with lots of concepts in math, it is best to look at a motivating example, that is, the kind of problem we might use this concept to talk about, and then from there see if we can sort of independently discover differential equations rather than just looking at a definition. So the archetypal motivating example for differential equations is population. So to keep this simple, we're going to talk about a population of bacteria. So for those who don't remember from high school biology, under ideal conditions, bacteria will divide, that is, each cell will divide into two new cells over every fixed interval of time. This is kind of an oversimplification, but let's roll with it. And to keep things simple, let's say that our bacteria divide every hour. And it should be pretty clear from this that the number of bacteria we have will determine the rate at which the population is increasing. The more bacteria we have, the more of them can divide during that hour. And so we want to therefore talk about the rate at which the bacteria are dividing, but that'll be in terms of the number of bacteria we have. So let's define t as the time in hours since we started, and define y of t as the number of bacteria at time t. Now, you may be used to thinking of y as a variable. Well, here we're going to talk about it as a function of time, because that way we can then talk about the rate that it changes with respect to time. Think of it as maybe in earlier classes when you would write y equals f of x, where f is a function of x. Think of it as sort of like that. So once we've defined that, we can define the rate of change of the population, dy over dt. And we read this as derivative of y with respect to t. That is, the rate at which the number of bacteria in the population is changing at a particular time. And in this particular case, we can just say dy over dt, or derivative of y with respect to t, equals y. That is, the rate at which it's increasing will be equal to the number of bacteria we have. Again, a bit of a simplification, but we're keeping things simple here. And that is a differential equation. That is, and now we can finally define it, it is an equation that relates a function to its own derivative. You see, we're saying that y is equal to the derivative of y with respect to t. Now, not all differential equations will be this simple. For instance, we can look at a few more examples that might look like some of these. Dy over dt equals y, dy over dt equals y plus t. Or we might even have like second derivatives. So we'd have, second derivative of y with respect to t minus 5 derivative of y with respect to t plus 6y equals 2. We could have that. Although a lot of these you might not encounter quite yet. So what we want to do with these usually, and there are a few different things we can do, but one of the big focuses will be trying to find a function that satisfies this. What is y of t such that its derivative is itself, or its derivative is equal to y plus t. And in this course, we're going to look at a few different ways to try to find that. So stick around. Thank you.